Hi there, and welcome to this lesson. And this lesson we'll be learning about coordinate geometry, okay? And under coordinate geometry, we'll be learning about the distance between 2 points. And at this point, I'd remind you to set the video to play in 1080p HD, okay? You can do so via the settings icon on the bottom right. And as the lesson progresses, if you have any issues at all, anything comes off as unclear, please feel free to get in touch. You can do so via the course dashboard. Okay, let's jump right into the lesson. So coordinate geometry, very interesting topic, coordinate geometry, very broad topic, coordinate geometry. And yeah, let's jump right into it. So at this point, I believe we're all familiar with geometry. Okay, everybody knows geometry, and then basically the study of shapes and their properties and etc. And but then coordinate geometry. Now I think we know a bit about coordinates. Coordinates are like points. Okay, I think you can work coordinates on the Earth's surface, but then like you could also consider coordinates in on a Cartesian plane. Okay, so Cartesian coordinates, i.e. on an XY graph. Okay, and yeah, what is coordinate geometry then? Now, coordinate geometry is the study of the properties of shapes, okay, in relation to their forming coordinates on the Cartesian plane. So very simply, we're going to have a graph, okay, an XY graph, and basically we're going to have different points in the graph, and we'll use these points to form shapes, and we'll be discussing the different properties of these shapes as they relate to the coordinates. Now, let's just understand all of this. So first we have the Cartesian plane, okay, and the Cartesian plane we have the x-axis and the y-axis. I believe we're all familiar with all of this. Okay, it's pretty much just plotting a graph. Okay, and basically going upwards on the vertical axis, the y-axis, we have positive numbers. Okay, going downwards we have negative numbers. To the right on the horizontal axis, the x-axis, we have positive numbers, and to the left we have negative numbers. So that is the Cartesian plane. Okay, and yeah, let's move on. So if we have a Cartesian plane like this, okay, and we have our x and y axis, okay, and I'm basically going to introduce some numbers here on the x-axis. So I have numbers 1 2 3 4 5 6 7 and 8 on the x-axis, and then I'm gonna go negative now and have -1 -2 -3 -4. Okay, just pretty much how you'd go about plotting a graph. And then on my y-axis I have 1 2 3 4 5. Okay, so now this is, we have a very laid out Cartesian plane. Okay, and I'm going to introduce a point. Okay, so I have a point here. Okay, and I'm going to trace this point down to the x-axis. Okay, so it's 2 on the x-axis. Okay, I'm going to trace this to the y-axis as well, and it's 2 on the y-axis. So we have 2 on the x and 2 on the y, and I'm going to call this point R, and point R is 2 comma 2. Okay, because we start with the x-axis 2. Okay, and then we do the y-axis, which is also 2 as well. Okay, but then this is how we write a point on the Cartesian plane. So this is point R, and we have in brackets we have 2, the value on the x-axis, comma 2, the value on the y-axis. Let's try another point. So I have this other point here, and I'm going to trace this to the x-axis, and basically it gives me 7. Okay, so I have 7 on the x-axis and 3 on the y-axis. Okay, and then basically I'm going to call this point Q, and Q in brackets we have 7 comma 3, because it's 7 on the x-axis and 3 on the y-axis. So we'll always put the x-axis first. Okay, so it's 7 3, not 3 7. Okay, so the x-axis always comes first and then the y-axis. Let's do another point. So I have this point here, and this point is -4 on the x-axis, and it's 5 on the y-axis, and we're going to call this point P. Okay, and I have P as minus 4 comma 5. Okay, so we have 3 points, and what I'm going to do now is I'm going to join these 3 points. Okay, and guess what? I've just formed a triangle. Okay, and I can now ask you to solve for the area of this triangle. And that is pretty much what coordinate geometry is about. Basically, we have different points that we used in forming a shape. Okay, and I'd ask you, using these points, I wouldn't give you any information regarding the triangle. I wouldn't give you any base or heights to use to solve for the area, but I ask you, using these points P, Q, and R, solve for the area of the formed triangle. And that is pretty much what we're going to be discussing in coordinate geometry. Okay, we're going to be learning to work with different shapes based on their forming points on a Cartesian plane. Okay, so the first of which is finding the distance between 2 points. Okay, so what is this about? Basically, if you have a Cartesian plane and you have, for example, if I told you, using the last example, I told you to find the length between P and Q, okay, i.e. P minus 4,5 and Q 7,3. How would you go about doing that? Because if you're going to solve for the area of that triangle, the first thing you need to do would be to obtain the length. Okay, so this is how you go about doing that. So the distance between 2 points, or the length between 2 points, now consider the figure below. Okay, now we have a Cartesian plane, and we introduce our axis, x-axis, y-axis, and now I'm going to introduce a point. So I have this point, okay, and then I'll trace this point down to the x-axis. Okay, at the moment I don't have any numbers on my axis, and I'm going to call this point x1. Okay, so it has a value x1, i.e. something on the x-axis. We don't know what it is, but it has a value x1 on the x-axis. Similarly, I'll trace it to the y-axis, and it'll have a value y1 on the y-axis. So basically, this is our first point, point 1. Okay, so point 1 has values x1 and y1. Okay, and I'm going to call point 1 A. Okay, or let's say point A. Now point A is x1 comma y1. Okay, so basically we're trying to draw a formula that will be able to use to solve for the distance between 2 points. Okay, and let's assume this is one of our given points, point A, and point A has values x1 and y1. Okay, so we have two values there, so x1 and y1. And now let's do another point. Okay, so I have point B, I guess that should be point B, and I'll trace point B to the x-axis. Point B has value x2 on the x-axis, and I trace to the y-axis, and point B has y2 on the y-axis. Okay, so point B is x2, y2. Okay, and now I'm going to draw a line joining point A and point B, and basically we're looking for this distance D. Okay, so we want to find D in terms of the points x1, y1 and x2, y2. And how do we go about doing this? Okay, so what I'm going to do now is I'm going to form a triangle like this. Basically, I just trace from the point the horizontal line at y1 and a vertical line at x2, and I'm going to form a triangle like that. Okay, and guess what? This is a right angle triangle. Okay, and then if you look at this triangle, you notice that the height of this triangle is y2 minus y1. Okay, because basically this is between y1 and y2, so if you're going to look for the length there, it will be y2 minus y1. Remember, we're trying to find D in terms of x1 y1 and x2 y2. Okay, and let's go back. So, and I look at the base of this triangle. Okay, so the horizontal length, and then basically it's between x1 and x2. It's x2 minus x1. Okay, x2 minus x1. So how do we relate what we have here? Okay, how do we find d in terms of y2, y1, x2 and x1? It's actually fairly easy. Okay, if you'd remember from Pythagoras' theorem, you have that when you have a triangle like this, the longest part, i.e. d in this case, is the hypotenuse. Okay, the horizontal part is the adjacent and the vertical one is the opposite. Okay, and if you were to find, there is a relationship between the hypotenuse, the opposite and the adjacent, in that you have that the square of the hypotenuse equals the sum of the squares of the adjacent and the opposite. Okay, and basically if you have that, you'd have that h would be the square root of the sum of the square of the adjacent and the opposite. Okay, now how can we relate this to what we have here? Because in this case we have the hypotenuse, the longest side is d. Okay, adjacent, the horizontal part, is x2 minus x1, and our opposite, the vertical part, is y2 minus y1. Okay, so it's pretty much just from the triangle you have there. Hypotenuse is d, opposite is y2 minus y1, and adjacent is x2 minus x1. And if we're just going to substitute those values into this formula here, we'd have that d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that is how you find the distance between 2 points. So we've basically gotten a formula that gives us the distance d in terms of the points a, x1, y1, and b, x2, y2. Okay, let's go ahead and apply this to an example. Okay, so example 1. And example 1 says find the distance between the points a 3, 2 and b 6, 4. Okay, now the first thing we need to do here, step 1, is we need to identify the relevant formula. We have d equals root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, and then right after that, the next thing we want to do is we want to identify our parameters. Okay, and in this case a will be the ones. Okay, so x1 in this case would be 3, y1 would be 2, and then x2 would be 6 for b, and y2 would be 4. So let's go ahead and do that. We have x2, x2 is 6. Okay, and our x1 is 3. Okay, x1 is a 3, and then we have y2 as 4, and we have y1 as 2. Okay, and just after that, what we need to do now is we need to put those values into our formula, and what we have is d equals the square root of 6 minus 3 all squared plus 4 minus 2 all squared. And then we have the d equals 6 minus 3, you have 3, and 4 minus 2, you have 2. So d equals 3 squared plus 2 squared root. And then you have that d equals the root of 9 plus 4. And you have that d is root 13. And I think that I don't think we can simplify any further. So we have d as root 13. Let's do another example. It's actually really easy. You just, once you know that formula, okay, d equals x2 minus x1 all squared plus y2 minus y1 all squared, square root. You pretty much don't have any problems from there. Actually really easy. Okay, let's do another one. So find the distance between the points p1 comma minus 2 and q5 comma minus 5. Okay, similarly, the first thing you want to do is you want to identify the relevant formula. Okay, we have that there, and then right after that we want to get our parameters out. So we have that x2 is 5. Okay, so x2 is in q, x2 is in point q, so we have 5, so our second x value. And x1 would be in p because p is our first point, so we have our first point x value there is 1. Okay, and then y2 is our y value on our second point, that is q, which is minus 5. Okay, and then y1 is minus 2, and then we'll go ahead and solve that. We have d, basically we put all our values in there, and then we have that 5 minus 1 is 4, and minus 5 minus minus 2, i.e. minus 5 plus 2 is minus 3. Okay, so you have 4 squared plus minus 3 all squared, square root of all of that, and then you have d equals root of 16 plus 9, because minus 3 all squared is 9 and 4 squared is 16. Then you have that d is root 25, and I think root 25 is 5. And that is, it's actually really easy once you understand the formula. Okay, and if you understand how we got to the formula, you should be able to remember it. All right, it's pretty much just Pythagoras' theorem. There really isn't much to it. You just have x2 minus x1 as your adjacent, y2 minus y1 as your opposite, and d as your hypotenuse. And once you know that, it's pretty much straightforward from there. Okay, so that would be it for this lesson. It's been a fairly short lesson. Okay, and yeah, bye for now.